Welcome to the AI Research Roundup. I'm Alex. Today we're looking at the GLM-4.5 technical report, which introduces a new family of models designed to unify reasoning, coding, and agentic abilities. The core idea here is to overcome the historical limitation of having different specialized models for different tasks. And the authors have had some real success. Their main GLM-4.5 model ranked third overall across 12 diverse benchmarks. As well see, the model's unique architecture and a specialized reinforcement learning process are key to this performance, especially when it comes to complex agentic tasks and tool use. So to really see this in action, let's look at the first set of results. This chart shows a big picture evaluation across 12 different benchmarks, comparing GLM-4.5 to other top models. The main bar chart at the top aggregates these scores, and you can see GLM-4.5 highlighted in blue, scoring 63.2 and landing in third place overall. The smaller charts below break this down into agentic, reasoning, and coding tasks. And agentic tasks, by the way, are where the AI has to act independently, using tools to solve complex problems. Building on that, this table drills down into specific reasoning and coding benchmarks. We can see GLM-4.5 scoring a very strong 91.0 on AIME24, a Math Olympiad challenge, and an impressive 98.2 on Math 500. This really shows its strength in complex logical tasks. A key reason for this is its mixture of experts architecture, which is like having a team of specialized mini-models inside, allowing the system to efficiently tackle different kinds of problems by routing the task to the most suitable expert. Now, shifting to its coding abilities, this next chart plots performance on a software engineering benchmark called SWE Bench against the model size, measured in billions of parameters. And what's really striking is that GLM-4.5 and its smaller version, GLM-4.5-Air, are positioned in the top left. This placement shows they achieve a very high score, around 64%, while being significantly smaller than many competitors. This demonstrates a fantastic trade-off between performance and efficiency, delivering top-tier coding ability without the massive scale of some other systems. And this efficiency extends to its agentic skills. These charts compare GLM-4.5 against other models on its ability to use tools. Now, tool calling is when the AI needs to use an external program, like a code interpreter or a search engine, to complete a task. The chart on the left shows GLM-4.5 has the highest success rate, over 90%. And while the chart on the right shows it uses a fair number of tokens to do this, the high success rate shows its process is very reliable. So what's behind this reliability? Well, this diagram lays out the multi-stage training process that builds these capabilities. It starts with a massive pre-training phase on general text, followed by a huge amount of code and reasoning data. After that, it moves into a more specialized mid-training phase. Here, the model is refined on specific datasets for code, then reasoning, and finally, on data for agentic tasks. You can also see the context length, which is the model's short-term memory, expanding dramatically from 4K to 128K tokens. And this diagram shows us a more detailed view of that final training. On the left, in stage 1, they create 3 specialized experts, one for reasoning, one for agentic tasks, and a general one, each trained with reinforcement learning, which is a method of learning from trial and error. The knowledge from these experts is then combined through self-distillation. This distilled knowledge then feeds into stage 2, where the final GLM-4.5 model is built through more supervised fine-tuning and targeted reinforcement learning, unifying all those different skills into one system. So, bringing all of that together, this sophisticated multi-stage training process results in a model that truly pushes the boundaries of unified AI. The main takeaway here is how GLM-4.5 manages to deliver top-tier performance across reasoning, coding, and agentic tasks, all within a single, highly efficient system. Its mixture of experts design is really the star, allowing for that impressive balance of power and scale. It's a significant step towards more versatile and capable AI agents. That's all for